Alright, so it's quarantine, and I thought I'd take some time and document everything that I've built over the past couple of years. And I'm starting with my 3 kilowatt Xenon Searchlight that I finished in October of 2019. So I thought I'd document everything before I head off to college, just so I can have something to look back at. And thought might as well share with anyone that's interested the process that I took in building this and how it works. Alright, so I'm going to start with the lamp house. The entire frame was built by me, as you can tell by these very interesting TIG welds. 6 hexagonal aluminum extrusions, and I used the sides of the extrusions to perfectly align the sides of the hexagon. And then the back and the bottom, it's concealed, is another aluminum extrusion just like this, welded to these poles, and that together makes the frame of the Searchlight. Alright. This, I'll probably talk more about it a little bit later, but this is a 16-inch rhodium electroplated parabolic reflector. I believe the focal point is at like 2.75 inches or something like that. Got it from Phoenix Electroformed. They sent it to me. And yeah, it works perfectly. I had no issues with it. Made a very nice, tight, concise beam. Alright. The side plates of the housing are made from these aluminum sheets. I believe I got them from Midwest Aluminum Supply Company. Well, I got them cut to the exact size I needed. So all I did was each piece, I would vice grip it to the frame, drill the holes exactly where they needed to be, and then just bolt it in. And yeah, on the side here we have an axis panel, which I can use for replacing the bulb or accessing the minimal amount of wiring that's actually in the lamp house, changing the fans, just like that, stuff like that. On the outside, we have our 2 connectors. This is for the igniter, the 35 kilovolt igniter, and then this powers the fans. Obviously, we got our positive and negative for the lamp. I think those are just welder plugs we got off eBay. They work really nicely. And then this polycarbonate piece that I salvaged from a laser isolates it from the aluminum. There's like a 1.5 inch gap around each side to prevent any high voltage interference. And then we got one of our 2 primary pressurization fans. So how this lamp house actually works is the reason that it's sealed is this bottom section is airtight, or as good as I could get it to be airtight. And you can see underneath the reflector all around, there is duct tape to prevent any air leakage. So when this bottom half is pressurized, and you'll see it better in a couple seconds, the air escapes through this hole. Usually I would have a lamp mount in there, but I took it out for this purpose so I could do a tour around it. But you can see the bottom of the lamp holder down there that actually clamps down the lamp and holds it. Yeah, so this is the other main pressurization fan. I had another fan that I originally installed in here, but the issue was that it actually wasn't powerful enough. It was a different model number than these other 2 fans, and when these 2 fans spun up, the air started rushing back out through here, and it would start turning the fan in reverse, and it would overheat. So I ended up just disconnecting it and then covering the hole up with some more duct tape. Looks a little sketchy, but it worked for the time being. Yeah, the fan is actually still mounted in there. You'll see it when I open up the access panel and do a tour inside. Yeah, I think that's pretty much everything outside. I think the biggest issues I had when I was building this lamp house was figuring out how to mount the reflector to the sides of the housing and make it like withstand the heat and be able to cool the reflector a bit, and also how to make this focusing mechanism for the actual lamp, this little holder down there, so that it can be electronically moved upwards and downwards, so I can get the arc of the xenon arc light in the focal point of the parabolic reflector, so I can get a very tight beam. And then while we're up here, this is the positive coming to the lamp. You can see it runs through there, and there's a layer of insulation around it because it goes through this aluminum plate which holds the reflector. And then here, where it's also close to some other metal surfaces, wrapped in some more electrical tape, make sure it doesn't arc over during the high voltage pulse sequence. And then up here I got a high voltage standoff. You can see it's just an air gap inside of there. And then this is where the bare aluminum wire going to the positive end of the xenon arc lamp would normally be. So the reason is, so usually top of the lamp would come to about, say, like 10-13 inches off the base of the reflector, and then I'd have a bare aluminum wire spanning it. And the reason it has to be bare is because the light outputted from this beam is so intense that having any insulation on there, it would just burn off in a matter of minutes. So I ended up having to use the bare aluminum wire that came with it. And yeah, no, I had no issues with it, no working problems. So I'll be right back. I'm going to open up that access panel and take a tour. I chose probably the worst material for filming to coat the inside of this reflector housing with. Very reflective. I apologize for the glare, but for the access panel, all it takes is a screwdriver. You can see the actual locking mechanism here, and it's a little bit tilted so that as you lock it, it seals it with this inner rubber gasket around this metal housing, and that means the access panel is also relatively airtight. Alright, we're going to start with, this is one of two main pressurization fans. You can see it in there. Very nice. This is the one that I sealed off. It's a thermocool. Did not have enough power, unfortunately. And there's the other main pressurization fan. Starting from the top, we can see the little focusing mechanism I made for the light. So this is the actual clamp that clamps onto the base of the arc light. And you can see I made this little worm gear driven focusing mechanism where this stepper motor drives this worm gear clockwise and counterclockwise, and when it turns counterclockwise, the focusing mechanism actually raises up, and counterclockwise raises it back down. Yeah, it's basically just a linear bearing worm gear drive. And you can see, because I was worrying about some of the heat traveling back down from this arc light base through here, and then into these linear bearings and possibly burning off the oil, I added a little aluminum heat sink that I made to the top half of the electrode holder. So this fan, this very powerful fan, blows air, circulating it, and then cooling the base of the electrode, making sure that the linear bearings stay relatively nice and cold. And powering the fan, little standoff to hold it off, is this little bit sketchy 12 volt 100 watt power supply. Alright, moving on, we can see this is the back of the terminal connections. We have 0 gauge negative going up. The negative snakes through here and bolts in right at the bottom of that electrode base. And the positive goes to one side of the igniter, and then the igniter is wired with series with the arc light, and I put on the positive end. I don't know, that's just because, I saw a couple other schematics of lamp houses online, and that's what they generally did. So I thought, even though it doesn't really matter, might as well. Don't want to be a precedent center in this situation, so I just copied them. And yeah, so you can see this is where I had some issues with mounting the light. So this frame, in the first couple 100 milliseconds that the igniter is on, is charged at 40,000 volts. So you can see I have the base of the reflector housing, this aluminum plate, some MDF, that's a hexagon, that's 2 inches smaller lengthwise. And then on that I have these insulating blocks to which I mounted this aluminum frame. And this aluminum frame is in fact directly in line with that negative. So when this igniter is on, there is some charge buildup on this frame, which is why it is so well insulated with these very thick plastic blocks. I believe they might be Teflon. I'm not really sure. I know that they're like for CNC machines for testing bit passes, so you don't have to use it on the actual metal piece. So yeah, no, they work very well for isolating the frame from the MDF and ultimately the grounded metal housing. Moving on, you can see the back, the 2 connections that I have coming in for both the igniter and the fans, going out to a little terminal breakout block. That is for the fans. That divides it up into 3 parallel connections to each the 3 pressurized, case pressurizing fans. And then to keep them away from this charged frame, I use the bolts that actually hold the MDF in place. Sorry, the little red wire in the way. To cable manage them all around until they get to their destination. They can go up into the fan, just to keep them away from this frame while the igniter is on, to prevent any high voltage going back into my house's line wiring. And you can see the same thing on this side. Just zip tied it to the top half of the bolt. Makes it easy to cable manage. Yeah, you can see I have these large copper lugs on the end of these cables, just so that I can handle the really high current. I believe that the lamp, when I was running it, it was running at like 110, 112 amps. So, you know, a little bit overkill. But those are also the smallest lugs I could find that actually fit over these like 1/2-inch bolts coming out of the igniter. Very large bolts. So yeah. And one last thing for the stepper motor, you can see that currently it is not plugged in. So after the lamp starts and the temperature stabilizes, what I do is I actually open up this access panel really quickly and run a little separate driver for the stepper motor that plugs in, and then I have speed control as well as direction control. So I can control which way it focuses and really get like a precise tight beam with that speed control. The reason being is when the igniter is on and it sends voltage up through the case, through the light, and down back into this frame, I don't want some of the high voltage to go into the stepper motor and then through these wires and killing my driver. So I end up just having a separate driver that isn't always plugged in, and I can plug it in manually. Not great, but it works. It works really well for my application. And then you can see this frame actually. It's a little bit hard to see, but I welded it, as you can tell from those very nice welds. If you couldn't tell, this was my first time learning how to TIG weld, and especially aluminum is not the easiest metal to learn TIG welding on. But, you know, these welds, they're nice and strong. They're not going to give up. But I had a couple of burn through spots, you know, like when you're learning welding, you're always going to burn through a bit. But yeah, no, this mechanism works really well. That just goes up and down, moves that up and down, and yeah, that's all on the electronic side. Now, for the actually mounting the reflector, you can see right up there in that little corner where the three edges meet. What I actually did is that aluminum plate up here. Let's see if I can point at it. This aluminum plate. Let's see if I can hit that. This aluminum plate. What I did is I first mounted that before I mounted the reflector, and I drilled some. Once I had it level, and I knew what height I wanted at, so that the range of the focusing mechanism wouldn't hit the light against the reflector. I had to calculate what height the actual platform would be, taking into consideration the range of motion of the focusing mechanism, how far in the reflector sits into the mounting plate, and the actual dimensions of the bulb. Beginning with the mounting of the plate to the frame, in that little corner right there, which I pointed to, I believe before the phone cut out, what I did is actually drilled a bolt through the frame exactly where I want it to be. Then I used some metal putty to secure the frame to that, and I roughed up the aluminum there in the edge so that the putty would have something to adhere to. That seems to work pretty well. And then for actually attaching the reflector to the metal plate, you can see I have some high temperature silicone, I believe it's gasket maker, that I just applied between the reflector and the hexagonal aluminum mounting bracket. And then you can see, because the aluminum mounting plate, that right there on the bottom, isn't welded all the way around, I have some, what's it called? It's just normal home use, I'm not really sure, putty, that usually people use to seal doors and windows, and I just applied that to the bottom, and then on all the edges, I used some more duct tape, sealed off all the edges, which proved really difficult to apply when the entire thing is already bolted together and there's a very limited amount of working space, but did it, and it works. So I believe that is everything. If I missed something or you want to see something I didn't cover, just, I don't know, put it in the comments section or something, and I might come back and film a little bit more in depth on it. But yeah, I think that's pretty much it. The big thing, once again, as I said when I was doing an external tour of the lab house, was deciding how this frame was going to look to hold the focusing mechanism, what the focusing mechanism actually would be, and how I would actually mount the reflector within the hexagonal aluminum frame. Yeah. Alright, let's move on to the power electronics. Here we have let me turn around, a Strong International Xenon power supply. I got this off of eBay from, I believe, a liquidating theater, and they use it to run their Xenon follow searchlights. They're like Strong Super Troopers or something like that. Not a very flattering name, but it works. As you can see here, if this thing will focus, it operates on one phase, which is good because I run it off split phase 120 volts. And it outputs 20 to 30 volts at 50 to 100 amps. The hard part was figuring out the wiring in here, because I got it just this box, no manual, no anything, and I had to sit while it was powered on with my multimeter and figure out the pinout. Going to all of the there's a little breakout terminal board that you'll see here in a second, that I had to determine which leads were what so I can actually use it with that. And yeah, all right, here. Hello. This is the inside of the Xenon power supply. You can see here come all the input connectors get distributed out. Here are the two very large lug connectors that go to the switching power supply, and through these two cables to the lamp house. Starting from up here, this is where the old input connector used to be. I actually ended up, you can see there's a breaker on this side that actually prevents overcurrenting, or sorry, that switches the power supply off if it draws too much current. And I ran these 12 gauge silicone wires so I could reroute the power to actually come in through here. You can see those two, these two silicone wires go through here in this bundle, and to that first contactor, which I'll get to in a couple of minutes. But all right, so this is the interface that actually controls the whole power supply. So this might get a little bit confusing, but basically connecting pins 4 with pins 6. So these two, what that actually does is it closes this contactor and switches on the power supply and provides power to the actual across the lamp. But you can see whenever I apply 120 volts through these wires, there's a little step down transformer that right there that actually provides power to all the auxiliaries. So it steps down to 120 volts, which then goes back out through here and actually route to the case fans. So the case fans in the lamp house actually only work whenever this power supply unit is on. I have some grounding here, just a common ground, very big lug, goes to this little distribution block, connects all the grounds, and this just goes, this little connector block that goes to the fans. Yeah, over here we have some rectification, very large filter capacitor. Basically what's happening here is power comes in through here, goes to the auxiliary transformer for powering the fans and such like that, and then contactor, when it closes, sends power through here to this DC filtering circuit, and then this is actually what powers the switching power supply. So this whole section is, I believe it's like a push and pull switching power supply. It might be an H bridge, but I'm not entirely sure. But we have the power transistors. We have 2 sets of 4 power transistors, which makes me believe that they work in push and pull for the 30 kilohertz switching rectification. And then you can see the actual 2 large output lugs are right there, and then that's what goes over to there. The way that this is cool is we have 2 large case fans just directing air through these 2 sets of heat sinks on the side that are on the back of the power transistors. That just cools the whole unit. A couple thermistors to prevent overheating. That's pretty much it. Oh, and this is the bridge rectifier that actually filters it out to DC. It actually supports 3-phase input, as we can see by those 3 legs, but DC comes out. I think that's it. Oh, yeah, I had a couple more more connectors that I didn't use, and as you can see for this, I patched up as well. not great looking, but I just it's like paper. It's like a paper-based wood composite. I just cut it to size and then I bolted it to the back. And it looked relatively nice. This one I had to electrical tape a bit more just to make it a little bit more airtight, but it ended up working all right. And then following this bundle of cables comes to this contactor box. So in this box we have 3 contactors that are controlling both the power supply and the igniter. First contactor, right there, oh god, there's a lot of glare, I'm sorry about that, is what sends power to the power supply. You can see the 2 10 or 12 gauge silicone wires coming into there. Second contactor uses only one of the 2 120 volt legs to get 120 volts, and then that sends the power through a line filter, and then that line filter through these red and black cables goes all the way through this bundle and then back out through here and to the igniter. I have a line filter in there to try to prevent any noise coming back in from the igniter, because all the igniter is basically just a spark gap with a pulse, with a very high turn ratio pulse transformer, and it makes a lot of electrical noise back on the other side, because every single time that spark gap discharges and sends a pulse into the primary of this transformer, it creates a lot of noise back into the system. So I had to create a little line filter there that filters out the majority of the noise. And this last contactor actually doesn't have any power going to it per se, but all it does is closes those 2 contacts. So when that contactor closes, it short circuits these 2 wires, which, if you remember me saying before, pins 4 and pin 6, when they're connected together, actually switch on the 120 amps going to the lamp. So all that's doing is, oh geez, a lot of glare. All that's doing is just short circuiting those 2 wires to switch on the high current going to the lamp. So typical sequence, the remote, which you'll see in a second. First I switch on this contactor, power supply initiates, it turns on the case fans. Once the case fans are spooled up, I close this 3rd contactor, which sends current across the lamp, but of course 20 volts cannot jump a 8 or 9 millimeter gap, or I believe it's actually 4 millimeters, 4 or 5 millimeter gap. So I momentarily switch on this middle contactor, and what that does is it establishes the arc inside the arc lamp, and that is what starts the searchlight. One last thing that I actually forgot to mention in this power supply is kind of hard to see, but in the back there is another little terminal distribution block with very thin wires. That actually goes through here, and you see the remote in a second, you'll see why that's there. But that doesn't actually go to the junction box. That just loops, makes a little U-turn right there, goes back up this wire. And here is the remote. These are what those 3 little wires go to. This is actually the current control potentiometer. Right now I have it set in, well, at almost full current. But yeah, that is what actually controls the amount of power going to the arc light. Alright, so this remote controls the contactor box, which actually controls the power supply. But first one closes the first contactor, sending power to the power supply, turning on the case fans. This one closes the 3rd contactor, sending the 120 amps across the bulb, and then this one, momentary switch, activates the igniter. And then up here on this screen, I have my voltage, amperage consumption of the power supply and all the fans running together, and multiplying them together gives you the consumption in terms of watts. Alright, we're almost wrapping this thing up, but yeah, not that much going on in here. I'm going to try to get through there. So, you can see this is the power cable. It has 4 conductors, ground, neutral, line 1, line 2. Each line is at 120 volts. I think I mentioned it before. I'm running it off split phase 240, which means that I've run off 120 volts to 180 degree apart 120 volt lines, which means at any one point in their sinusoidal progression, you're going to get 240 volts across them in potential. So both lines go to this first contactor, but then for the second contactor, I only use one of the legs to power the 120 volt igniter, and the other leg actually powers this case fan, which keeps all the wiring in here cool. A little bit overkill. Nothing really heats up in here, but better. I don't know, I had an extra fan. Yeah, a little bit of strain relief in there. Hose clamp. Not very good. I think I wrapped it with some more electrical tape before I hose clamped it to prevent any, here, I'll zoom in at that, to prevent any, it cutting into the wire. It's pretty sharp on the edges. And then when it's running through this sheet metal case, I have some more electrical tape around there to prevent any cutting. And then, yeah, this is the cable I have that runs to the junction box. The plug I have on here is just a standard dryer plug. In my house, we have a natural gas dryer, so the dryer plug ends up being a very convenient and pretty much free real estate place for the for me to use my Searchlight. Very sketchy connections. Yeah, that's pretty much it. There really isn't too much to this. I started this project back, I believe, summer of my freshman year of high school. And then that summer is when I got my reflector and this power supply. And then I just finished. I took a pretty long break in between everything, with school and some sports. So I ended up only getting to the lamp house and taking the time to design it the fall of my senior year. So this whole project took me 2.5 years to complete, and I'll have some beam shots at the end of the video